Hi, all. We are talking about reflection. And here's the scenario. I have a mirror right here. I'm at my desk, as you can tell, and there's a document camera looking straight down. So this is just a flat, what we call a plane, P-L-A-N-E, plane mirror. And I want to talk about what's called the law of reflection. So I'm about to shine a laser light. Here's my laser. And I'm going to shine a laser light, if you can see that. I'm going to shine a laser light along this arrow. We call those arrows rays, just like a ray of light. Well, it's a ray of light. It is a ray of light. So the ray represents the direction, of course, the light is traveling. And if any light ray that is going in towards a boundary of any sort is called the incident ray. I wrote it down here in my lovely handwriting. Incident ray. The incident ray is the light ray on its way in. I'm shining it all at this point right here. Any light that comes that reflects off is cleverly called the reflected ray. So when here's the mirror boundary right here, and our reference line for all angles, this is true with reflection and refraction and other things, we always don't actually measure the angle to the surface of the mirror, which would make sense, I understand, but there is a reason later on why will make sense why we don't do that. So we always measure it to wherever the light's going to hit. I'm going to have it hit right here. We measure it to this point that is at 90 degrees to the surface, and we call that the normal. You remember the normal force, normal meaning 90 degrees or right angle. This is called the normal. It's a normal line. And all angles of incidence and reflection, and later on angles of refraction in the next lesson, will always be measured to the normal, not to the surface. So here's my normal. It's just an imaginary line drawn perpendicular to the surface where the light ray hits. So I've drawn 3 light rays, one along 30 degrees to the normal, another light ray I can shine in at 45 degrees, measured to the normal, and another one at 60 degrees to the normal. And when I do this, so if I shine this light along here, you can see it reflect on the other side. That's at 30 degrees. I'll do 60 degrees. So 60 degrees to the normal, you can see it reflect on the other side. I kind of missed. The one I'm really interested in, because I have it completed, is 45 degrees. And so if it comes in at 45 degrees, notice that I have already drawn the reflected ray, and it reflects along that reflected ray, which also happens to be 45 degrees. So the law of reflection is very simple. It says that the angle of incidence on one side of the normal equals the angle of reflection on the other side of the normal. The angle of incidence, if the angle of incidence is 30 degrees, the angle of reflection would be 30 degrees to the normal on the other side. And the one I already have drawn at 45 degrees, that's at 45 degrees over there. The angle of incidence equals 45. The angle of reflection equals 45 degrees. I do want to show you something that's kind of interesting. See how this works. If you look along, it doesn't work too well, but this is a little awkward. You can see the image in the mirror, sort of. As I go along, it's weird to hold this way. You can actually see the reflected image as it goes in. Oopsies, I can't see this anymore. My bad. I'm almost done. The reflected image, as it went in here, you saw it go into the mirror. Maybe you saw it, but the main point here is that the angle of reflection equals so the angle of incidence equals the angle of reflection. All right. I'm going to stop this.